Good day, everyone. I welcome you back to Global Education Zone, the home of impactful learning. It's nice over here for you and I because learning never ends and education is the key to an impactful life. I welcome you back to Global Education Zone, and in this video, let's talk about algebraic processes and lineal and quadratic equations. So in this episode, we'll be talking about linear and quadratic equations. I will be talking about all you need to know in order to answer these equations, and then lastly and most importantly, I'll be dealing with exercises on linear equations and quadratic equations. And then we'll also be doing a simultaneous linear and quadratic equation. We'll also be plotting the graph on an axis. So let's delve into this exercise without much delay. Now, basically, in a previous episode in the SS2 courses, I talked about the fact that you can make use of different methods in order to solve your quadratic equations. Now, in that particular episode, we talked about the completing the square method, we talked about the quadratic formula, we talked about factorization, we talked about perfect square method, and so on and so forth. Now, in this particular episode, this is SS3 course, and in this SS3 course, we'll be doing revisions of most of those, and then in this particular revision, let's talk about those methods. So now, to solve a quadratic equation, first of all, it means we are looking for the roots of that quadratic equation. And what is a quadratic equation? It simply means an equation that has a the highest power of the unknown as 2. So, or you can also say that the order of that equation is 2. The order of an equation is the highest power of any term in that equation. So the highest power of a term in the equation is 2. So you can see something like x squared, you can see like xy, you can see like y squared. So, but just know that the order of that equation is 2. And then to solve this equation, we need to arrange the equation in the form of ax squared plus bx plus c equals 0. Now, when we write something like this, ax squared plus bx plus c, this is a quadratic expression. But when we make equate it to 0, that will be a quadratic equation. So basically, you rearrange all the terms and fix them on one side of the equation. So in this case, we are fixing them on the left hand side. So the reason is that when you fix on the left hand side, you will be able to use the fact that the product of two numbers pq is 0 when either of the numbers is 0. So that means when you factorize, you are going to use that knowledge to say, okay, if pq is equal to 0, then either p is 0 or q is 0. And if both are 0, it still satisfies the condition. So now this is the simple semantics and structure of quadratic equation. Now let's talk about if a quadratic expression does not factorize, what do? You make use of the quadratic formula. Now in the SS2 episode, I derived the quadratic formula, and this SS3 episode, before you watch this SS3 course, please make sure you have at least you have watched the SS1 course, the SS2 course. At least before you watch the SS3, make sure you watch the SS2, because the SS3 is basically a buttress and a revision of the SS2 course. And if you have not watched the SS1 course, you can also watch it too, because mathematics is kind of like a ladder of knowledge. So you keep climbing, and you keep building on previous knowledge. Now, I talked about this, right? So this is the approach, and the quadratic formula is basically equals to your unknown equals minus b plus or minus root b squared minus 4ac. So everything is, and then divide everything by 2a. So also know that this a is the coefficient of the highest order of the unknown. So this is x squared. X squared, as I mentioned earlier, that a quadratic equation has the highest power of the unknown as 2. So the term that has the highest power of the unknown, the coefficient of that term is a. So that's a is the coefficient of the term that has the highest power. Then next we have the b. Then the next lowest power, which is b. Then the lowest power of x, which is c, as their respective coefficients. So the coefficient of the highest power is a. The coefficient of the next highest power is b. The coefficient of the lowest power is c. So that's how you know it. For example, in an equation, in a sample equation, like for example, when we have 2x squared minus 3x equals to let me see what we can do about this. Equals to 1. Now in this particular equation, what you do is you arrange it so that you can get it in this form of ax squared plus bx plus c. So that means you are going to subtract 1 from both sides. That will be 2x squared minus 3x minus 1 equals, when you subtract 1 from the right hand side, it becomes 0. So you can see that we have gotten it in the form of ax squared plus bx plus c. So we have 2x squared minus 3x minus 1. So when you compare both equations, you can see that ax squared will be equal to 2x squared, and that means a will be equal to 2. Then next you have bx squared, b plus bx is minus 3x, so b will be what? Minus 3. B is equal to minus 3. Let me make it clearer. B equals minus 3. And then lastly, you can see that c equals minus 1. So if you are using the quadratic formula, you just plug in these values for your equation. You plug them into the formula, and then you will be able to get your answer which satisfies the equation. So if you can try it, you can also try it. You can just plug in your b minus b plus or minus root b squared minus 4ac, and then that would be what? Minus your b is what? Your b is minus 3 minus 3 plus or minus roots b squared is that's minus 3 square minus 4 times a is 2, and c is 1 minus 1. So that will be, divide everything by 2 times a, and a is 2 times 2. That will be minus times minus 3, that's 3 plus or minus roots. Our b square is minus 3 square, the square of minus 3, that will be 9. The reason for that is that minus 3 times minus 3 is plus 9. So the square of minus 3 is 9. Then we have minus 4 times 2 times 1 is 4 times 2 times minus 1 is minus 8. Then minus 8 is plus 8. Right? Am I right about that? Yes, plus 8. So we're right about that. Then we divide everything by 4. So you can see that here we have them here. B squared minus 4ac. Now, having done that, what we'll do is you begin to evaluate the term in the bracket. So I'm not really sure about this. It looks like this c was supposed to be I'm not really sure. I guess it was supposed to be 1. Let's make this c 1. So plus 1, so that we'll be able to get a value, a reasonable value. So c will be 1, and this will be minus 1 on the right hand side. So when I've changed the value, that means you are going to add 1 to both sides in this time around. So when c is 1, that will be minus 4 times 2 times 1, that's minus 8. So I don't want us to get square roots. That will be, so x will be what? 3 plus or minus root. 9 minus 8 is 1, root 1 over 4. That will be, so either x is 3 plus root 1 over 4, or x is 3 minus root 1 over 4. You know root 1 is 1, so x will be equal to, x is 3 plus 1 over 4, or 3 minus 1 over 4. So that means x is what? 4 over 4, that's 1, or x is 2 over 4, that's 1 over 2. So x is 1 or half is the solution of this quadratic equation. Now you might not be able to know the extent and the implications of all these calculations, but they can be able to go really far in many applications in mathematics. Because even real life applications, for example, one time you want to calculate even geometric applications. One time you want to calculate the region occupied by a space. Even it's applied in many of these aerospace and engineering companies. So for example, one time you want to calculate even in satellite imagery and ranging. For example, you have to know the region where an object can be found. So you make use of the equations of geometric shapes. For example, equation of a circle, and then at the end of the day you can get something like this. And most of this personnel, for example, what if in that case your computer goes down and then there's no light and there's no electricity, and then you are left with this equation. So, and this equation will tell you the location of an object from space. So and then you are trying to just imagine that. So and imagine that you don't know this formula. Imagine you don't know the quadratic formula. So that would be like a bummer, like it'd be a big bummer. So this is very important. You might not realize, but it's applied in very diverse and various ways. And this secondary school mathematics, it's very important for you to take it serious, no matter who you are, no matter where you go. So because if you can hold on to these basics, you can always build upon those, and then you will be surprised how widely you can apply them, and you can prove yourself to be a scholar. Now, all that being said and done, that is what we'll be doing about the theory. So now let's talk about the practice. Let me give some examples. And then I'll give you one example on a single linear equation, and then I'll give you another example on a simultaneous linear and quadratic equation. So let's talk about the linear equations. So let me give an example. A lorry travels a distance of 240 km at a uniform speed. If it had been 4 km per hour slower, it would have taken 2 hours more to cover the distance. Find its speed. So here we are saying that let the speed be x km per hour and the time taken be 240 over x hours. So if the lorry travels 4 km slower, the speed will be what? X minus 4, because if the speed initially is x, so if you travel slower, you are reducing the speed, and the new speed will be what? X minus 4. So in this kind of questions that involve speed and distance and journey and whatever, now anytime you are going faster, you are increasing the speed. Anytime you are going slower, you are decreasing the speed. Anytime you are going faster, you are decreasing the time. Anytime you are going slower, you are increasing the time. So I would like you to understand speed and time as inverse relationship, because in your equations you often have this that distance is equal to speed times time. This speed, and as a result, speed is equal to distance over time. So they are inversely proportional. So in this particular question, the time taken in the second instance will be 240 over x minus 4. So we can now equate that if it takes 2 more hours, when we subtract the time for the first one, which is 240 over x minus 4, because when we travel slower, the time increases, so the second time will be greater than the first time. So that means that 240 over x minus 4 minus 240 over x equals to, then when we solve that equations, you are going to get, at the end of the day, you get a quadratic equation. Now imagine this is a real life equation, and assuming you are a policeman and then you are trying to find the distance and speed of the lorry who has broken the traffic regulations, and in this case you are left with, at the end of your bogus and extraneous calculations, you are left with a quadratic equation. Then there are no computers to calculate them, though I know there are calculators, but assuming there are computers but you don't know how to use those computers, so what do? You are going to be left with your wits and your methodology. So this is very important. So you can see that you can, at the end of the day, you make use of the factorization method. If you don't know the factorization method, I've discussed it in the SS2 video on quadratic equation. You can always check that out. You are free. And if you are of the type who knows some topics and there are still some topics you don't understand, but those topics are few, instead of downloading the whole course, you can just pick out the videos of the course that you are having issues with, and then you can use them to thrash out your difficulties in mathematics. So this is always possible and you can always improve. Now this question, at the end of the day, we have the speed of the lorry as 24 kilometers per hour. Hurray. Now that question is a demonstration of your quadratic equations using the factorization method, and I assure you, if you plug in your value of the coefficients of your different powers of x in this quadratic formula, you are still going to get that your final answer. You will get something like this. You are going to get 2 answers. So just a tip here, the tip I'm going to give you is that anytime you have a linear equation, your number of solutions is always 1. So anytime you have a quadratic equation with a power of 2, highest power of 2, your number of roots will be always 2. If you have a cubic equation with the highest power of 3, your number of solutions will be 3, and so on and so forth. So if you have an equation with the highest power of n, your number of solutions will be n. So in this mathematics, we are not limited to 3 cubic equations. In higher mathematics, advanced methodology, we make use of different higher and highest power. Apart from cubic, we make use of even quintile and equations that have the highest power as 5. So in that case, you have five roots, and just imagine how many possible locations you can be able to get from that equation. So but today, let's limit ourselves with the limit of secondary school mathematics. Now next, let's talk about the next part of this video, which will be talking about your simultaneous linear and quadratic equation. Now in a particular episode of our SS2 course, I talked about simultaneous linear and quadratic equations, and in that episode I talked about it in sufficient detail. I even did examples, so it was very interesting. So let's talk about this one now. Now, making use of simultaneous linear and quadratic equation, let's use that equation to solve a question. So now, solving the question, we have solve the simultaneous equations 3x squared minus xy equals 0 and 2y minus 5x equals 1. So if you've watched the video in SS2 course, you would have known how to solve this. But if you haven't, let me show you how to do it. So you have 3x squared minus xy equals 0 as equation 1. Then you have 2y minus 5x equals 1 as equation 2. Then next you have from 2 you make y the subject. That means 2y equals 1 plus 5x, and further you divide both sides by 2. So that means y equals half open bracket 1 plus 5x. Then next you now substitute that new value of y into the equation 1. So that means you anywhere you see y, you replace it with half the sum of 1 and 5x. That will be, and when you substitute that, you get, at the end of the day, you have a quadratic equation, which is half x open bracket x minus 1 equals 0. So that means when you manipulate that, you have x equals 0 or x equals 1. So that means if you substitute your values of x, you are going to get the corresponding values of y. So when x equals 0, what is y? So when x equals 0, y is equals to what? Half. And when x equals 1, y is equals to 3. So you can represent your answer as other pair of solutions. So that means you can say 0, half and 1, 3. So that is the those are, if you represent that on the Cartesian plane, those are the combination of points that satisfy the regions that's specified by the simultaneous linear and quadratic equations. So now, so far we've gotten this far, and then thank you for being with me to the end of this video. And at this point, we're going to talk about what we'll be doing in the next episode. Now, before that, let's talk about the revision. So in this episode, I talked about your quadratic formula. I gave an example relating to your factorization method, and I talked about how your simultaneous equations and your quadratic and linear equations can be applied in the future practically. So, and then I talked about lastly, I gave an example on simultaneous linear and quadratic equations. Now, next video we'll be talking about the graphical method. Now, up till now I've been talking about graphs and I've not been able to demonstrate practically. Now, in the next episode we are going to be talking about graphs and how to plot graphs from equations and vice versa. Thanks for watching. See you next episode.